Now let's look at an application problem interpreting slope. A swimming pool is being filled with a hose. The water depth y in feet in the pool t hours after the hose is turned on is given by y equals 1.5 t plus 2. A, find the slope and y-intercept of the graph of this equation. And B, what do the slope and y-intercept represent? Right, so first of all, A, let's find the slope. Well, that's not too hard, right? It's already in slope-intercept form, right? So the slope is going to be the coefficient on t, so the slope is 1.5. And the y-intercept is 2, right? That's what's being added in. All right, so now that we've identified the slope and the y-intercept, let's interpret what those mean. Let's start with the y-intercept. Okay? So remember that the y-intercept is the value of y when x is 0. In this case, x represents, it's t. In this case, it'll be when t is 0. Right? So y equals 2 when t equals 0. Right? So the t here represents time. So when no time has elapsed, since y is referring to water, right? Y is the depth of the water. The pool has a depth of 2 feet of water. Right? So that's the starting amount of water. So the water, before we start filling the pool up, right? So the pool has 2 feet of water before we begin filling. Right, so that's basically what our y-intercept means, right? So it's our starting value, right? Before we start doing something, that's how much we have. So before we start filling up the pool with water, there's 2 feet of water in the pool. Now 2 feet of water, that's like a wading pool here. So we want to put some more water in the pool. So our slope here is 1.5. Notice it's positive, right? So positive slope indicates we are filling the pool. The amount of water is increasing, in other words. All right, but how much are we filling the pool? All right, so let's look at our units here. All right, so y is feet, and t, so it's, remember, slope is change in y over change in, and in this case, change in t. I'll put that over here. Actually, I'll put it in red. Slope is change in y over change in t. Y is measured in feet. And time is in hours. Right, so we are filling the pool, so the water is increasing. The amount of water in the pool is increasing at in this case it's a constant rate because this is a linear function, at a constant rate of 1.5 feet per hour. All right, and there we go. All right, so we have interpreted the y-intercept. Right, it's our It's how much water the pool is starting with. And we've interpreted our slope, right? Positive slope, we are filling up the pool, the amount of water is increasing, and the amount of water is increasing at a constant rate, in this case, of 1.5 feet per hour. Right? When you're in calculus, you will have to interpret units. Units are extremely important on all of a lot of things the work we do in calculus. So this is a good start with that. All right, good review on that. So thanks for watching, and bye for now.